Okay, multiplying radicals. We've simplified radicals, we've added radicals, we've subtracted radicals. Next is multiplying radicals. Guess what's after that? Dividing, you're right. So if we look at these two radicals, the square root of 12 times the square root of 15. We can think of the square root of 12 as really the square root of 4 times the square root of 3. The square root of 15 is really the square root of 3 times the square root of 5, right? And whenever you have two square roots that are the same multiplying together, the square root of 3 times the square root of 3, that equals 3. Right? Because the square root is a number that times itself would be that number, so blah, blah, blah. The square root of 4, as we know, is 2, and then we got the square root of 5. Okay, so what is 2 times 3 times the square root of 5? 6. Square root of 5. Make sense? Okay, let's try this one. Square root of 15, well, we're going to bring that down to the square root of 3, square root of 5. Here's a random 2. And 12, that's the square root of 4, square root of 3, right? Okay, neither of these are perfect squares. We can't do anything with this. This 4 is going to turn into a 2. And then here we have the square root of 3 and another square root of 3. The square root of 3 times the square root of 3 is 3. And then we have this 2 right here. And then the square root of 5. Right? Now we've rewritten this. Square root of 3 times the square root of 3 is 3. There's that random 2. Square root of 4 is 2. And then the square root of 5. 2 times 3 is 6. Times 2 is 12. 12 square root of 5. Okay, now we can see that here we have the square root of 2 and the square root of 6, right? We can't get any perfect squares out of these, but we can get the same number. Negative 1, this is a negative 1. Now here we have the square root of 3 times the square root of 2 equals 6, right? And then we got the square root of 2. Well, the square root of 2 times the square root of 2 equals 2. Now we have negative 1 times 2 square root of 3. Negative 1 times 2 is negative 2 square root of 3. Make sense? These are not that difficult. They're kind of fun. Let's try this one. We have the square root of 3. I'm going to put this negative 2 in front of everything, okay? Because it doesn't really matter. Multiplication is commutative. I can move it. And then there's 15. That's the square root of 3, square root of 5. These two square roots are the same. So the square root of 3 times the square root of 3 equals 3. Negative 2 times 3. And then the square root of 5 is left over, right? These two square roots of 3 became 3. Negative 2 times 3 is negative 6. Square root of 5. Okay, last one of these really super simple ones with the square root of 5. Square root of 20 times the square root of 20. Any number, the square root of a number times that same square root of that same number is just the number. So this is negative 5 times 20. That's negative 100. What if there's distribution? It's like a parenthesis, and you have to distribute something from the outside. Just remember that cats can only multiply with cats. Dogs can only multiply with dogs. Radicals can multiply only with other radicals. And numbers are numbers. Radicals are radicals. They can't multiply by each other. So when I go to distribute this radical 5. Here I have a number, and there I have a radical. Well, that's just going to be 2 radical 5. Put the plus. Now these two radicals, though, I can multiply those two together. 5 times 10 is 50, right? Okay, so if I could take this, so we could make that into a 5 and a 10, but that wouldn't help us. Let's make it 25. Uh-oh, hold on, the eraser here. Stroke eraser. 25 and 2, okay? Well, the square root of 25 is 5. So now I have 2 square root of 5 plus 2 times 5 is 10 square root of 2. And these radicals are not the same, so we can't combine them. Right? Remember we learned about that when we were adding radicals? That's all we can do. Okay, let's try this one. Radical 5 times radical 10, that's radical 50, plus radical 5 times radical 6, that'll be radical 30, right? Well, 50 can go down to radical 25, radical 2. 30 doesn't have a perfect square that can come out of it. So we're going to just leave that as a 30. So 25 goes down to 5 radical 2 plus radical 30. Is that right? Okay, let's try this one. Now we have a number and a radical on the outside. So both of these together are going to multiply by those. 2 times 5, those are both numbers. They're not radicals. They can multiply together. 2 times 5 is 10. Radical 10 times radical 5 is radical 50. There's an invisible 1 in front of there, right? 2 times 1 is 2. Radical 10 times radical 2 is radical 20. Well, we already know that we can make this 50 go down to 25 and 2. Now we can make this 20 go down to 4 and 5. And the 4 goes down to 2. 25 goes down to 5. So now we have 10 times 5 times radical 2 plus 2 times 2 times radical 5. 10 times 5 is 50. Radical 2. 2 times 2 is 4. Radical 5. And the radicals are not like terms, so we cannot combine them. Okay, let's try this one. You know that there's little ones in front of here, right? Negative 3 times 1, negative 3. 15 times 6, 90. 15 times 6, 60 plus 30 and 90. Okay, negative 3 plus negative 3. 15 times 10, 150. Okay, are there perfect squares that we can pull out of these? Well, sure, 90 can go down to the square root of 9 times the square root of 10. And 150 can go down to square root of 25, square root of 6, right? 6, yeah. Okay, so 9 will be a 3, 25 will be a 5. Negative 3 times 3 square root of 10 plus negative 3 times 5 square root of 6, right? See the negative 3, 3 square root of 10, negative 3, 5 square root of 6. Negative 3 times 3 is negative 9 square root of 10, oops, plus, that's really kind of, there, we'll just make it so we can read it, huh? plus negative 3 times 5 is negative 15 square root of 6. Now, I don't really need to have this plus sign in here, do I? Because that's a negative, it's going to be a minus. So goodbye. Negative 9 square root of 10 minus 15 square root of 6. Last one of these, okay? Now we know there's a little 1 in front of there, right? And that's the number that's going to be multiplied by the numbers. 1 times negative 4 is negative 4. Now we're going to multiply radical by radical. 30, radical 30. 1 times negative 5 is negative 5. 5 times 10 is 50. Okay, 30. There are no perfect squares that can come out of 30, so we're just going to leave that as radical 30. Is there a perfect square that we can factor out of the 50? Sure. 25 and 2, right? Well, square root of 25 is 5. So now we have negative 5 times positive 5. That's negative 25. And then that random radical 2 there. Make sense?